Today I would like to present about some facts that I gained through the learning outcome based on chapter 1. So basically chapter 1 consists of 6 subtopics. Okay, so chapter 1 of electrical fundamental circuit is basic concept. Okay, basic concept. Under that we have 6 subtopics, which is the first one, system of units, electrical charge, current, which voltage, power and energy. All these are in terms of just definition without merely calculation in it. And circuit element. Actually circuit element is needed because we are drawing circuit, so we need to know the elements and the characteristic behaving under that element. So introduction of the basic concept of electrical circuit is its definition, which is the electrical circuit definition. We make it as a prime scope first. Is the interconnection of electrical elements, which means the interconnection of the elements which constitute the circuit element itself. As an example, the components that we use in the electrical circuit is basically resistor, okay, capacitor, okay, inductor, and other sources like voltage source or current source. Okay, so coming back to the first subtopic of basic concept, is the system of unit. So now, system of unit, it constitutes of 7 basic units. 7 basic units. So which is length, mass, time, electric current, temperature, amount of substance. Basically in electrical circuit scope, we are not using amount of substance because this is morely introduced in chemistry based learning. And intensity, luminous intensity. Actually this is more in light effect actually. So the basic unit of all these 7 is, for length it's meter, okay. For mass it is kilogram, which is we denote it as kg. This is m, kg, okay. Time we got second. Electric current we got ampere, okay. Temperature, this is all the SI unit of the basic unit being written here. So temperature we got Kelvin, amount of substance we got mole, so luminous intensity we got candela. So this is in short meter, kg, second, ampere, Kelvin, mole, and candela CD. Okay, so we finished about basic quantity. Okay, so now we are going to electrical charges. Electrical charges, okay, we go on to the core definition of charge. Okay, charge is an electric property, okay, of the atomic particle in which it is measured in coulomb. Okay, so the atomic particle consists of electron, proton and neutron. Electron is the negatively charged particles, proton is the positively charged particles, and neutron is the compensation in the nucleus of the atom. So illustration of an atom is being visualized by Bohr atomic model, because it is said that atom have an planetary type of structure, so it actually behaves like kinda circular in motion, randomly moving, so it's just vibrating here and there, so it's just a free random movement. Actually particle move in a specifically classified movement called Brownian movement. So charge, the constant for charge is let me tell you about the value of electron constant first, which is 1.602 times 10 to the power of negative 19 coulomb. So if you want to know what is the value for 1 coulomb, we just divide the value of the constant value of electron. So it's just like this, 1 over it will give rise to 1 coulomb, because this is 1.602 times 10 to the power of negative 19 coulomb. So this is basically what we are learning in electric charges. So it's just a basic description. So going on to the third subtopic, current. So current is the amount of charge. Okay, that flows from a point to a point over a period of time. Okay, so it's a flow over time. So that is what we call as current, and it's measured in ampere as what we told before. So the unit of ampere can also be derived as 1 coulomb over time, because it is the amount of charge which is in terms of coulomb over a period of time. So we get 1C over T makes up 1 ampere of current. So current have two types of current, which is AC current, which the graph just a linear like this, and DC current of this, and AC current graph. Since we know alternating current, it's periodically reverse in direction, so the graph must be in sinusoid wave. Okay, so this is how the AC current graph acts, and this is how DC current, because it has no change of direction. So this is current, and we would like to talk about on voltage. Okay, the next scope is about voltage. Okay, voltage. Voltage is the energy required, is the E, energy required to move a unit of charge. So voltage moves ampere, which is the electrical charge, through an element. Element, it means that electrical element, which is measured in volt. Okay, so the unit of voltage is volt. So it can be written as this. So voltage can also be defined as the potential difference between 2 points, because the potential difference of that 2 points will give rise to the energy that is used to move a coulomb of charge. Let's say 1 volt. So in 1 volt, it is the potential difference which is used to move 1 coulomb of energy. So we can say that it is proportional, where the potential difference needed and the amount of energy used will be proportional. So voltage is needed to pass through energy from one point to another. Okay. So now we move on to power and energy. Okay, power and energy. Power is the rate of energy. So we know when there is a term rate, sure there is an operation dealing with period of time. So we can conclude that power is energy over time. So we can conclude that power is equals to W over T, because power is the energy used over time, because it is a rate of energy used. So that is power. And now we move on to the last part of basic concept.